We have talked about differentiation, taking two functions, and we said calculus is nothing but relating two functions. And if I take the same example, like function 1 is height and function 2 is slope, going from function 1 to function 2 gives us the method of going from function 1 to function 2 was differentiation. Integration or integral is going in the reverse order, which is going from function 2 to function 1. Which is, if we know the slopes at different time, whether we can find out what is the distance covered. Okay, how much height is traveled. So if we try to understand that method or the basis of integrals, how we do is, let us take a simple arithmetic approach. Suppose the slopes are like at one instant it is 0, next instant it is 1, then 4, 9, say 16. This is how the slopes are, or this is how the heights are. If we want to find out what is the change or what is the slope of that, we always take those. The change between these two is 1. Change between the second and the third element or the second interval is 3. Here it is 5 and here it is 7. These are the changes in y. How to get to y? Our target is from the second function we want to get the information on first function. So if we see this, that during the first interval what we have done? 1. During the second interval, if we do 1 plus 3, I get where we reach to that, which is 4. Again, if I do the running summation, 1 plus 3 plus 5 gives you 9. And again 1 plus 3 plus 5 plus 7 gives you 16. That means summation of delta y is giving you the information about y at different instant, provided we take running sum of them. So each interval, if we know the differences of the slope we have attended, the sum of them is going to give you the value of y or the first function. This is the arithmetic approach. If we do an algebraic approach, suppose we say the positions are, these are the values of y. We say it was y0 at an instant 0, then y1, y2, y3, y4. If we do like that, then if we want to find out the changes happened in each interval, this interval the change is y1 minus y0. This interval the change is y2 minus y1. This interval the change is y3 minus y2. And like that, this is y4 minus y3. If we sum them up, what we get? We get, summing them up, you can see by adding these two consecutive, we are getting y2 minus y0. That means summation is giving me the information about the first function by adding them up. So if we add all of them and write, so summation of delta y, all the delta y is nothing but, you see y1 will cancel, y2 will cancel, y3 will cancel, but only two elements which will remain is y4 and y0. So it is the last element minus the first element. What does that mean? That means it is the total distance traveled during that time, and that's what we are looking for, a total height covered, where we know the individual slopes attended at different intervals. So this is where from we get the information of the first function from the second function by summing up all the second function. So integration is adding up, summing up all of these differences or the slopes whatever we have done. Now if I want to write these in this limit form or in this calculus form, which is taking the limit when delta x is tending to 0. That means we are splitting the second element information into more and more fractions. We are getting this. So if we want to write this in calculus form in a limiting order, what we can write this is nothing but delta y. I can divide both of them, divide and multiply, and apply the limit. Delta x is tending to 0, that means we are splitting into small and smaller fraction. This is nothing but the first component gives you, what is this? This is nothing but dy dx, so we are getting dy dx, which is nothing but the slope, multiplied by dx, which is the limiting value or limiting approach of this particular change. So this is what we talk of. And instead of summing up in calculus, we use exactly the same thing, which is Sx. If I write this, so the slope function, the second function, multiplied by its width and summing up all of them. This is the symbol for integration. So value of the second function multiplied by its width, which is nothing but each and every area. That gives you the total information about the first function. Let us take an example, calculus example rather, to see the implementation of integration or this concept what I have been explaining using arithmetic, algebraic and calculus approach. Let us take a very simple function. The function, we will be taking the second function. So Sx is 2 minus 2x. But if we plot these on a simple graph, this is Sx, which is the slope, and this is x for different values of x. This is how it is approaching. We can plot this taking x equal to 0. We can see that s is 2, so probably we can take that as 2. And when it is meeting, where it is meeting x-axis, when if I take x equal to 0, we get this as 2, as I have said. And to get y or Sx, which is our variable slope, to be 0, if we put x equal to 1, we see that this is where it is becoming 0. So this is 1, which is giving you the slope, the graphical presentation of this. So if I join these 2 points, it gives you the information about the slope. Now our target is to get the information of the distance covered or height covered from this, which is nothing but if we split these, what we have seen that this is Sx into dx, where x is this. So if we split this into maybe small fragment of 4 elements of each one is 1 by 4 and I draw them, I get like this. These are the segments which are equally 4 segments along x, and we get a rough estimate of that. If we want to find out what is the area under this, we take some approximation that okay, let us make this as each one as rectangle. This is also a rectangle like this, and we get an approximate value. You can see that by calculating these areas, I am not getting very accurate result because my delta x or dx is not so small. They are, each one is 1 by 4 unit. So I am seeing these areas, like if I darken them, I am getting them as x's in my calculation. How we can make it more and more accurate? I will draw another example, another diagram for the same. Let us take this is 2 and 1. If I can split these into very small segments instead of doing bigger ones, you see that each case we are getting an area extra over our defined function reduced to a very small amount. So if we can make it even smaller and smaller, if we can split it into very large number of fractions, that means we are talking of this approach where delta x is tending to 0, this particular product or the summation of the products is going to give me the perfect area. Let us do this. This is what it is, and we want to find out using the approach of integration. What is the, in reverse process, we have shown that how we can get a function. Like if I go back to differentiation, we have seen yesterday that x to the power n gives us differentiation of x to the power n, our basic function, gives us n x to the power n minus 1. Power gets reduced by 1 and the original power comes to the front. Now if we want to find out the first function, in this process we have gone in the forward direction and we have differentiated, and as I stated, integration is just the reverse process. So if we want to find out what is the first function if the second function is x to the power n and going in the reverse direction. So if we want to do that, we know, we can see clearly that its power will increase by 1, so we get x to the power n plus 1, but the differentiation of x to the power n plus 1 will give you another factor here, n plus 1 factor, and this will reduce to n. So to match with the right hand side, we have to divide this by n plus 1. We follow the same method in this to find out the first function by mathematical approach. We see that integrating 2 will give us the first function, which is yx will become 2x, because differentiation of x is 1 and that 1 comes to the front, it makes no change. The second case, if I do, I can see that I'll get, to get x by differentiation, so my original function has to be x square. So I take x square, there is a 2 here, and this x square, by this method I have to bring it down, so that means I am getting this 2 here. So integration of this thing is going to give me x square by 2 into this, so this is nothing but 2x minus x square. Its differentiation will match with this. Okay, this is how we understand how the integration operation is. Now if I want to draw this graph and find out how the second function would be, the first function would be based on our second function, if we can take what was the value, or what would be the value of the function at when we are at 1, we can see that clearly. This is going to give us, when we are at 1, so x is going to give us 2 and this is 1, so we will get 1 here. Okay, that's what is the distance, and we can see that from this graph here at 1, what is this area? This is, we have a height 2, we have a base 1, half base into height into 2 into 1 means it gives you an area of 1. So that means we are talking of at 1 second the height achieved is 1. If I take at half, what is this value? We can find out again from this. If I put x equal to half, this becomes 1, this becomes 1 by 4. So we are somewhere around 3/4. So if this is our 1, so this will be 3/4. And if we continue, we'll see that this is what is the function which is taking different values or different heights or distances. If we talk of, instead of height and slope, if we talk of distance and speed, we get this as the graph for the first function. This is how we can find out integration is the process by which integration means we are talking of different areas under the second function curve within the variable. That's the area which is going to give us the information about each and every point, what is the distance or height traveled.